We are going to take a look at geometric series test for convergence. So a geometric series is the one that you studied in like algebra 2 or pre-calculus. That's the one that fits this format here. So there's going to be first term and then times r to the power n minus 1, and you're going to go from 1 to infinity. So the condition here is it's going to converge all the time when the absolute value of r, which is the common ratio, is going to be less than 1. And if it's greater than 1, the absolute value of the common ratio, then it's going to diverge. We are never going to use 0 or 1 as the common ratio. It's not allowed. So if it fits the condition for convergence, then the sum is going to be, you can actually find the sum, and this is the expression. So it's the first term divided by 1 minus with the common ratio. You do need to be careful with evaluating the first term. It's not always apparent, so you need to be careful. So let's take a look. So the question is going to be for all these problems if it's evaluate if possible, or otherwise you're going to state that it diverges. So first we're going to need to check the condition. So here the common ratio is 2/3. So you can see here it's very much like the formula. So it is, if you take the absolute value, it's still 2/3, it's less than 1. It is good, and we can find the sum. We are going to have our first term in this case, because it completely fits the structure, the first term here is going to be 2. But you can always check this by substituting this value into the formula. So if 1 minus 1 gives you 0, so anything to the power 0 is 1, and you're going to get 2. Okay? And then, so it converges, and it converges to, we can find the sum, which is going to be the first term divided by 1 minus the common ratio, and that's going to be 2 divided by 1/3, and that's going to give us 6. So example 2, in this case the common ratio is 3/2, and since it, even if you take absolute value, it's still greater than 1, and it is going to diverge. Please remember that there is actually a situation, well, it's if you take the common ratio and you plug it into the formula for the sum, no matter what it is, you will get a number. What I'm trying to say here is, even if the value of r exceeds 1, the absolute value of r exceeds 1, you can still plug it in and you will get a number. The problem is that answer will not be correct, because if the absolute value of r is less than 1, the sum is going to diverge, and which means it's going to be infinity, and you're not going to be able to evaluate the sum. So diverges, and that's it. You just stop there. Alright, here, the next one. So first of all, let's see. We got 2/5, so that is our common ratio. But you have to be very careful with the first term. So what we do is we're actually going to substitute the first value, which in this case is 0. We're going to substitute this here. And 2/5 to the power 0 is going to be 1. Again, this is less than 1, so you are going to be able to find the sum. So it converges. And we are going to get 1 divided by 1 minus 2/5, which is going to be 1 divided by 3/5, which is going to give us, 5/3. Okay? This one. So we got this expression. We can clearly see that the value of r is 1/3. So it's going to converge, less than 1. To find the first term, you need to be very careful, because as I already mentioned in the previous problem, just because it says 1 here does not mean that this has to be 1. 1 here is just a notation that we use that represents the first term. The first term actually here is going to be associated with the n equals 2. So it's going to be 3 times 1/3 to the second power. This is what it's going to be. So it's 3 times 1/9, which is 1/3. All right. So to find it converges, and it's going to be 1 divided, no, it's going to be, I'm sorry, 1/3 divided by, because it's the first term, divided by 1 minus 1/3. So it is 1/3 divided by 2/3, which is going to be 1/2. All right. A couple more problems. So here we have decimals involved, but it's going to work the same way. So here the common ratio is 1.1. That number, even with the absolute value, is going to be less than 1. I'm sorry, greater than 1, so it's going to diverge. This here is going to be, the common ratio here is going to be 0.7. That's right, just 0.7, which is less than 1. Our first term is going to be when n is the first number here, which is 1. So it's going to be 2 times 0.7, which is actually going to be 1.4. So it's 1.4 for the first term. So it's going to converge. And it's going to be the first term 1.4 divided by 1 minus 0.7, which is 1.4 divided by 0.3, which can be simplified to 14/3. Okay, and this is how it's done. And I hope this helps. See you next time.